Okay, Assalamualaikum warahmatullahi wabarakatuh. Morning class. Okay, so now the next subtopic for gas law is the Dalton's law. So but before that, let us recall what are the gas law that you have learned previously. Okay, so we have learned about Boyle's law, Charles, and also Avogadro's. Okay, so if these three gas law is combined, we'll get PV equal to nRT. Okay, so PV equal to nRT, whereby we can use the PV equal to nRT to calculate the gas, the molecular mass. Okay, molecular mass. Okay, the concentration, and also density. So what is Dalton's law? So Dalton's law of partial pressure states that since the gas molecules are far apart, we can assume that they behave independently. Okay, so they have their own pressure. Okay, so Dalton's law of partial pressure. So means that it has its own partial pressure. Okay, so we can say that the total pressure of a mixture of non-reacting gases is the sum of the partial pressure exerted by each of the constituent gas in the mixture. So let's say we have PA and also PB, means that we have component A and component B mixed together, and component A will exert its own partial pressure and component B will exert its own partial pressure. If both of these two components are mixed together but non-reacting towards each other, so the total pressure that is exerted by both of the component is the total pressure. Okay, P total. Okay, so this is what we call as Dalton's law. So the partial pressure of the gas is defined as the pressure it would exert if it was alone in the container. Okay, so means that in this case, the container that we use to to calculate the partial pressure of gas A and partial pressure of gas B is the same. Okay, so for gas A, we use the ideal gas equation PA equal to NART over V. Also for PB, NBRT over V. So note that the volume are the same, constant volume. Okay, constant volume and constant temperature. Okay, so we move to question number 6. Dalton's law of partial pressure. This is the calculation. Okay, so 3 liter of closed cylinder contains a mixture of 11.25 gram of nitrogen oxide and also 33.95 grams of nitrogen dioxide at temperature 27 degrees Celsius. So this one is 300 Kelvin. Okay, this one is V, 3 liter. Assume that the gases are not reacted with each other. So first, you need to calculate the total pressure of the gas mixture. Okay, so the total pressure of the gas mixture. Okay, so we use the formula P total equal to N total RT over V. Okay, means that N total is the mixture of mole of nitrogen monoxide plus mole of nitrogen dioxide. Okay, so the number of mole of nitrogen monoxide is 0.375 mole and number of mole of NO2 is 0.7380 mole. So this gives the total mole which is equal to 1.113 mole. Okay. Okay, substitute the value into the formula. So 1.113 times with R 0.08206 times with 300 Kelvin over volume 3 liter. So you will get the P total in ATM. Okay, so the value of P total is 9.13 ATM. So this is for question 1. Okay, B1. And for question B2, calculate the partial pressure exerted by each of the gas. So partial pressure exerted by each of the gas means that we want to find the partial pressure of nitrogen monoxide and partial pressure of NO2. So the partial pressure of nitrogen monoxide, since we know that this is the number of mole of nitrogen monoxide, 0.375 mole over with N total 1.113 times with 9.13 ATM. So you will get the first partial pressure of nitrogen monoxide. So in ATM, so the same method we use to calculate the number of the partial pressure of nitrogen dioxide. Okay, so you will get the answer. So note that the total of partial pressure of nitrogen monoxide, okay, partial pressure of nitrogen monoxide plus partial pressure of nitrogen dioxide is equal to P total. Okay, equal to P total. Okay, so next. Okay, from the questions, we have two tanks, which is tank A and tank B, that are connected by a closed valve. Okay, tank A is filled with 7.5 liter of methane. So this one is containing methane for tank A with the pressure of 3.5 atm. So it is from the figure, okay, stated, okay, as the information given. Okay, whereas tank B is filled with 5.75 liter of nitrogen gas at 6.2 atm. Both gases are held at the same temperature. Both tanks, okay, both tanks are held at the same temperature. Okay, then the valve is turned on. Okay, so turn on here, and both gases are allowed to mix. Okay, so means that gas A will move to tank B. Okay, methane will move to tank B, and we have nitrogen gas will move to tank A. So means that is a mixing. Okay, the mixing process is happening. Okay. Okay, the question asks, what is the ratio of the number of mole of methane? So N methane over with number of mole of nitrogen gas. Okay, N methane over N nitrogen gas. Okay, so what we should do here? Okay, do we have the number of mole? We don't have the number of mole. Therefore, we need to relate. Okay, what are the information that we have right now? We have only the volume and the pressure. Volume and the pressure. So note that when the valve is turned on, so means that gas methane and nitrogen will mix. So the volume, okay, for methane in tank A is 7.5 liter. Volume of tank A 7.5 and volume of tank B is 5.75. So means that V total is equal to 7.5 plus 5.75 liter. So you get the number, the volume of total volume for the mixture. 13.25 liter. Okay, so what should we do? We know that before the valve is turned on, okay, we can say it as condition 1. Okay, and after the valve is turned on, we will get the condition 2. Means that we will have the change in volume and also change in pressure. So means that we can relate with Boyle's law, whereby P1 V1 equal to P2 V2. So this is for methane gas. Okay, methane gas. So P1 for methane is 7.5 liter times with 3.5 atm. So 3.5 times with 7.5, and P2 is the partial pressure that we need to calculate, and V2 is 13.25. Okay, solve for V2 for methane. Okay, also, sorry, not V2 but P2. Okay, P2 for methane. Okay, also you complete, okay, the calculation for P2 for nitrogen gas. So P1 V1 equal to P2 V2 means that you have 5.75 liter and 6.2 atm. 6.2 times 5.75 equal to P2 for nitrogen gas times with its volume when the valve is turned on, which is 13.25 liter. Okay, solve for P2. Okay, so this one is atm. This is also in atm. Okay, so the value for P2 for methane is 1.98 atm, and for nitrogen gas, the P2 is 2.69 atm. So next, we need to find how do we solve, okay, the ratio. Okay, the question asks for the ratio. So we relate the partial pressure of methane and partial pressure of nitrogen with the number of mole. Okay, so in the previous slides, we know that partial pressure of methane, okay, is equal to N methane RT over V. Okay, then the number of mole, the partial pressure of nitrogen. For nitrogen, we can write mole of nitrogen RT over V. Okay, so if we want to find, okay, the ratio of methane to nitrogen, number of mole, we can use from the formula. So we have RT over V for methane, RT over V for nitrogen, so it will cancel out. Okay, therefore you will get ratio of mole of methane over mole of nitrogen. So it means that we only calculate the partial pressure of methane over partial pressure of nitrogen. Okay, still it is the same value as we find the mole ratio. Okay, so we place it here. For methane, 1.98 over 2.69 for nitrogen. Okay, so the answer is 0.73. Okay, 0.73. So this is the ratio of number of moles, 0.73 of methane per 1 mole of nitrogen gas. Alright, so next, water displacement method. Okay, so water displacement method is the method that we use to synthesize the gas and collect them by displacing a volume of water. Okay, so if we have a reaction, okay, from a heating process, from the experiment, we heat our sample right here like this, and it will dissociate and produce gas. Okay, so the gas will be transferred, okay, into the water. Okay, so into the water. Okay, so here right here now we can see that this is the water level, and after the reaction have ended, the experiment has ended, completed. So it means that we can see this is the water level. So means there are gases that are collected, okay, above the surface of water in the container. Okay, so here we will say that the gas that we collect is P gas plus PH2O vapor. Water vapor has also have its own pressure, partial pressure. Okay, so P total is atmospheric pressure. Okay, atmospheric pressure. Okay, so let us look at the calculation for this type of question. Okay, a sample of oxygen gas is collected over water at 20 degrees Celsius. So this is the temperature, okay, and a pressure of 738 torr. So 738 torr is the atmospheric pressure or P total. Okay, and the volume of the gas is 310 milliliter. Okay, so this is 0.310 liter. So given that the pressure, the vapor pressure of water is 17.5 torr, what is the partial pressure of oxygen? So oxygen is collected over water. So it means that we have here, okay, a sample that is collected, the gas, oxygen gas that is collected over water. So we have a mixture of oxygen gas, and at the same time we will have the partial pressure of vapor pressure of water, okay, PH2O. So this one is equal to atmospheric pressure, P atmospheric. Okay, so therefore P atmospheric pressure from the question is 738 torr. Okay, so PO2 unknown and PH2O 17.5 torr. So solve for PO2. Okay, the partial pressure of oxygen is 720.5 mm/Hg. So we have completed for question 9A. So next, what would be the volume of oxygen when it is dry at STP? Okay, so what is the condition at STP? Okay, STP standard temperature is 0 Kelvin, 0 degrees Celsius which is 273 Kelvin, and pressure is 1 atm. So this is the standard temperature and pressure. Okay, so this condition that we get from the question, okay, we can label it as T1, and the partial pressure of oxygen is P1, okay, is P1, and the volume is V1. So the number of mole are the same, okay, the number of mole are the same, therefore we can use the combined gas law. So P1 V1 over T1 is equal to P2 V2 over T2. Okay, solve for for V2. Okay, you can solve for V2. Okay, for T1 the temperature is 293 Kelvin. P1, okay, we substitute P1 V1, so P1 is 720.5. Okay, V1 is 0.310 liter over T1 293 Kelvin equal to P2, which is 1 atm. Okay, so 1 atm is 760 mmHg. Okay, this one is 760. Volume is the value that we need to calculate. And T2 is 273. Okay, solve for V2. How many liter? Okay, so V2 is 0.274 liter. Okay, or 274 ml.